Hello everyone, today I'm going to show the solutions of questions section 1 to 3 review on page 36. I'm going to start with question 2. Question 2 says that we'll find the mass in grams of 2.00 moles of nitrogen and 3.01 times 10 to the power 23 atoms of chlorine. Here, to solve this kind of questions, first of all, you must see what is the given in the question and what is the unknown. So then you're going to put the relationship between them. Mole and mass. We see the relationship between mole and mass. So I'm going to convert mole to mass. To do this, I need the constant relation between mole of nitrogen and mass of nitrogen. This is called as the molar mass. 1 mole of nitrogen makes 14.01 grams of nitrogen. 2 moles of nitrogen makes 28.0 grams of nitrogen. So if 1 mole of nitrogen makes 14.01 grams of nitrogen, then 2 moles of nitrogen make the double of this number. It's going to be 28.0 grams of nitrogen. And why I wrote 20.0? Because 1, 2, 3, there are 3 significant figures in my question. So result must contain 3 significant figures. Okay. In question B, we have 3.01 times 10 to the power 23 atoms of chlorine. Question 1 says convert how many mass or what mass they make. We know 6.022 times 10 to the power 23 atoms of chlorine make 35.45 grams of chlorine. This is the constant relation between number of atoms of chlorine and its molar mass. 1 mole of chlorine makes 35.45 grams of chlorine. This can be found in the periodic table. And 1 mole of chlorine contains 6.022 times 10 to the power 23 atoms of chlorine. So if you combine two equalities, 6.022 times 10 to the power 23 atoms of chlorine make 35.45 grams of chlorine. Then by using this conversion factor, you can easily convert 3.01 times 10 to the power 23 atoms of chlorine into grams. So it makes 17.7 grams of chlorine. In the question, there are 3 significant figures, so the result must contain 3 significant figures. Okay, now question 3. Find the number of moles in 12.15 grams of magnesium. I can understand. I'm going to put the relationship between mass of magnesium and its mole. 1 mole of magnesium makes 24.31 grams of magnesium. Then 12.15 grams of magnesium make 0.4998 moles of magnesium. As you see in the question, there are 4 SF significant figures. So result must contain 1, 2, 3, 4 significant figures. And in question B, find the number of moles in 1.50 times 10 to the power 23 atoms of fluorine. Here, to convert number of atoms to mole, you need to know the relationship between number of atoms and the mole. 1 mole of all the pure substances contain 6.022 times 10 to the power 23 particles. Or we can say 1 mole of any pure substance contains Avogadro's number of particles. Okay, so I can say 1 mole of fluorine contains 6.022 times 10 to the power 23 atoms of fluorine. And then 1.50 times 10 to the power 23 atoms of fluorine. How many moles? To do this, we need to put this formula. This is the conversion factor. 1.50 times 10 to the power 23 atoms of fluorine times 1 mole of fluorine over 6.022 times 10 to the power 23 atoms of fluorine. Atoms of fluorine, as you see, can be simplified. 10 to the power 23, 10 to the power 23 can be simplified. And you're going to get the result as 0.249 moles of fluorine. It means 0.249 moles of fluorine contain 1.50 times 10 to the power 23 atoms of fluorine. Okay, let's continue with the solution of question 4. Find the number of atoms in 2.50 moles of zinc. Here we will convert mole of zinc into number of atoms. Here we should know the relationship between number of atoms and the mole. It's like the dozen. 1 dozen of anything makes 12 particles or includes 12 particles. So we can say mole is a counting unit like dozen. So 1 mole of any pure substance contains 6.022 times 10 to the power 23 particles. So I'm beginning my solution with the given in the question. It is 2.50 moles of zinc times, I'm going to write here the same unit with the unit given in the question. It's going to be mole. And the desired unit is number of atoms of zinc. Number of atoms of zinc. So I know 1 mole of zinc contains 6.022 times 10 to the power 23 atoms of zinc. By using my calculator, 2.50 times 6.022 times 10 to the power 23 makes 1.51 times 10 to the power 24 atoms of zinc. If 1 mole of zinc contains 6.022 times 10 to the power 23 zinc atoms, then 2.50 moles of zinc contain 1.51 times 10 to the power 24 atoms of zinc. When this number of zinc atoms are together, they make only 2.50 moles of zinc. And here in question B, I'm going to convert 1.50 grams of carbon into number of atoms. So here I'm going to establish the relationship between mass of carbon and number of atoms of carbon. 1 mole of carbon includes 6.022 times 10 to the power 23 carbon atoms, and when this number of carbon atoms are together, they make only 12.01 grams. This mass is called as a molar mass. It can be found in the periodic table. So I'm gonna start to my solution with the given question: 1.50 grams of carbon times, look, 6.022 times 10 to the power 23 atoms of carbon. They make 12.01 grams of carbon. This gram of carbon contains this number of atoms of carbon. So I wonder 1.50 grams of carbon contains how many atoms of carbon? (1.50 times 6.022 times 10 to the power 23 over 12.01 makes 7.52 times 10 to the power 22 atoms of carbon. Okay, 7.52 times 10 to the power 22 atoms of carbon make 1.50 grams of carbon. And this relation is a constant between molar mass of carbon and the Avogadro's number of carbon. 1 mole carbon contains 6.022 times 10 to the power 23 atoms of carbon, and 1 mole of carbon is equal to 12.01 grams. So I can say 6.022 times 10 to the power 23 atoms of carbon make 12.01 grams of carbon. So you establish a conversion factor as you see in my solution. You multiply this number by this number and divide the result by this number. As you see here, gram of carbon is they are cancelled, and the resulting unit becomes atoms of carbon. Okay, let's go on with question 5. Determine both the formula mass and molar mass of ammonium carbonate. Here, formula mass, what's the meaning of formula mass? Formula mass is the mass of a single molecule of a compound. Molar mass is the mass of 6.022 times 10 to the power 23 molecules of a compound. Here, first of all, I'm going to find the formula mass. Then I will find the molar mass, but we will see at the end formula mass and molar mass of any compound are numerically equal to each other. Let's find that? This is the formula of ammonium carbonate, NH4 by 2 CO3. To find the formula mass, you need the average atomic masses of each atom exist in the formula. To find the molar mass of any compound, you need the molar mass of each element exist in the formula. Here I have, let's write here a title. This is the calculation of formula mass. I have 3 atoms of oxygen. 3 oxygen atoms times 1 oxygen atom. Its average atomic mass is in unit of AMU. It is 16.00 AMU. Okay, and it makes 48.00 AMU. And here we go with carbon. I have 1 carbon atom in the formula times 1 carbon atom makes 12.00 AMU. It makes 12.01 AMU. And here I have 8 hydrogen atoms. You multiply this number by the subscript of hydrogen, you get 8 hydrogen atoms. There are 8 hydrogen atoms in 1 molecule of ammonium carbonate times 1 hydrogen atom makes 1.01 AMU. It makes 8.08 AMU. And nitrogen, I have 2 nitrogen atoms times, this is the conversion factors part as you see in my solution. 1 nitrogen atom makes 14.01, I think. Let me check it out. Yeah, it's going to be 14.01 AMU. So nitrogen atom, they can be cancelled. 2 times 14.01 makes 28.02 AMU. Addition of these results will give us formula mass of this molecule. Let's sum them. 48.00 plus 12.01 plus 8.08 plus 28.02 makes 19.11 AMU. So this is the formula mass of ammonium carbonate. This is the mass of only 1 molecule of ammonium carbonate in unit of AMU. Now, question says also find the molar mass of this compound. Here we need the molar masses of each element that exists in the compound. I'm gonna write the title here: molar mass. Okay. In this compound, I have 3 moles of oxygen. Look, I'm here using 3 moles of oxygen times 1 mole of oxygen makes 16.00 grams. They make 48.00 grams. Look, and I have 1 mole of carbon. 1 mole of carbon, directly we can write, it makes 12.01 grams of carbon. It makes 12.01 grams of carbon. And I have 8 moles of hydrogen. 1 mole of hydrogen makes 1.01 grams. 8 mole of hydrogen makes 8.08 grams. And I have 2 moles of nitrogen in 1 mole of this compound. 2 moles of nitrogen. 1 mole of nitrogen makes 14.01 grams of nitrogen. So 2 moles make 28.02 grams. Okay, my friends, first of all, I must give the definition for molar mass. Molar mass in a compound is equal to mass of 1 mole of this compound. So in 1 mole of this compound, I have 2 moles of nitrogen, 8 moles of hydrogen, 1 mole of carbon, 3 moles of oxygen. I convert moles of each element existing in this compound to their moles. To their masses. 3 moles of oxygen makes 48 grams, 1 mole of carbon makes 12.01 grams, 8 moles of hydrogen make 8.08 grams, 2 moles of nitrogen make 28.02 grams. When you sum this mass of oxygen, this mass of carbon, this mass of hydrogen, and this mass of nitrogen, you will get the molar mass of this compound. So as I told you in the beginning of this solution, formula mass and molar mass are numerically equal to each other. So this summation will give us 96.11, but the unit of molar mass is gram per mole. 1 mole of this compound makes 96.11 grams. So this is the molar mass of our compound. Molar mass. Yeah. Okay. And now let's continue with the solution of question 6. We have 3 questions left. How many moles of atoms? Look, the question is find the mole of atoms of each element are in 1 mole of ammonium carbonate. Okay. Let me read the question again. How many moles of atoms of each element are there in 1 mole of ammonium carbonate? This is what we did in the previous solution. I have the compound ammonium carbonate, and this is 1 mole, okay? This is 1 mole of ammonium carbonate. In 1 mole of ammonium carbonate, I have 3 moles of oxygen and 1 mole of carbon. Subscripts of elements determine the mole of atoms of each element. And 8 moles of hydrogen and 2 moles, 2 times 1, 2 moles of nitrogen. You will sum them. 3 plus 1, 4, 4 plus 8, 12, 12 plus 2, 14. I have totally 14 moles of atoms. Now we continue with the solution of question 7. Question 7. What is the mass in grams of 3.25 moles of iron 3 sulfate? This iron 3 sulfate because the subscript of iron in this compound is +3. As you know, some D block metals have different charges. For this reason, their names are shown by or written by using a Roman numeral. It is the iron 3 sulfate. Okay, first of all, to find the 3.25 moles of iron 3 sulfate make how many grams? We need to find the molar mass of iron 3 sulfate, because molar mass of iron 3 sulfate will supply us, or we can understand, 1 mole of iron 3 sulfate makes how many grams? By doing this solution, you are calculating the molar mass of iron 3 sulfate. You have 12 moles of oxygen, 3 moles of sulfur, 2 moles of iron in this compound. So you convert moles of each element to their masses, as you see. Then you will sum the masses of these elements, and you will get 399.91 grams per mole. This is the molar mass of iron 3 sulfate. It means 1 mole of this compound makes 399.91 grams. So now you can easily convert 3.25 moles of iron 3 sulfate into gram, because you know 1 mole of this compound makes this gram. So moles of iron 3 sulfate, moles of iron 3 sulfate can be simplified. Multiply this number by this number. Get the result. 1,300 grams of iron 3 sulfate. So simply I can say 3.25 moles of iron 3 sulfate by mass, it makes 1,300 grams. Okay, in question 8, how many molecules of aspirin C9H8O4 are in a 100.0 milligrams tablet of aspirin? So first of all, this is the most important point of the question. Mass of aspirin is given in terms of milligram. So milligram first of all must be converted into gram, because in all of our solutions we use the unit of mass in gram. So 1,000 milligrams make 1 gram, 100.0 milligrams make 0.1 gram. Okay, I have 0.1 gram of aspirin. I wonder how many molecules make 0.1 gram of aspirin. To find this, you need to find the relationship between number of molecules of aspirin and its mass. This is the relationship between its Avogadro's number and molar mass. To do this, you need to calculate the molar mass of aspirin. This solution shows us the calculation of molar mass of aspirin. You have 4 moles of oxygen in 1 mole of aspirin, 8 moles of hydrogen in 1 mole of aspirin, 9 moles of carbon in 1 mole of aspirin. Then you will convert each mole into mass. Then after summing them, you will get 180.17 grams per mole. This is the molar mass of aspirin. It means 6.022 times 10 to the power 23 aspirin molecules make 180.18 grams. Then we are calculating how many molecules of aspirin make 0.1 gram. To do this, we need to apply this calculation. 0.1 gram of aspirin times 6.022 times 10 to the power 23 molecules of aspirin make 180.17 grams of aspirin, and this calculation gives us 3.342 times 10 to the power 23 molecules of aspirin. I can write make 0.1 gram or 100.0 milligram. Okay. I'm showing the result like this. Is it good? I don't know. Okay. Thank you for watching.